Live.
Good morning, everyone. My name is Matt Williams, and I am super excited to welcome you to this year's DevOps Days Seattle. The organizing team for the day has worked really hard to make sure the right talks are selected, that there is time to talk with everyone, and that the right sponsors are in place to help make sure everything gets paid for. Over the course of the day, you'll learn new aspects and points of view on what is DevOps and how has it changed our lives. We'll start the day with Emily Freeman's talk about distributed DevOps. Emily is an amazing speaker who I first met at RevolutionConf a few years back in Virginia Beach when she talked about code craftsmanship and Dr. Seuss. I'm sure today's talk will be just as incredible. At the end of her talk, we'll have 20 minutes where you can ask questions and Emily will be on hand to answer them. I do hope Dr. Seuss makes an appearance. We'll repeat that sequence a number of times throughout the day. 20-minute talks followed by a 20-minute Ask Me Anything session with the speaker. The Ask Me Anythings are going to be done in the Discord. You can find the complete agenda along with the times each talk starts up on the Seattle DevOps website. We're going to stick to that schedule throughout the day. So if there are any talks that you might not find interesting for whatever reason, then just take a note of the time that either the discussion start or the next presenter is on. 2 times during the day, we'll break things up with Ignites. These are 5-minute super condensed talks that are, in my experience, far more difficult as a presenter to get ready for. My own Ignite at DevOps Days Austin a few years back, setting up a music system at our office, was one of the toughest I have ever done. They're a little different in our current online world, but they will all be a lot of fun. Finally, at the end of the day, we'll have a panel discussion with Taylor Barnett, Kat Gosgrove, Katie Farmer, and Arathi Ramani about the stresses and challenges we have all experienced in architecting and designing systems to scale. And of course, we're all working from home, so you just heard my daughter saying, bye-bye, Daddy. I am here to keep the sessions moving along and to be your guidepost as we move through the day. In my day job, I'm an evangelist and trainer at Datadog, where I get to learn about new technologies and share them with everyone I meet. This is a note that this is a DevOps Days event. At this point, I would normally ask for a show of hands of how many have been to a DevOps Days event somewhere in the world. But that doesn't work so well in this online environment. So I hope that you will all visit this Discord and share your DevOps Days experiences with the group. I'm going to assume that this is the first for many of you, and I hope it is not the last for any of you. I have done 10 or so as an attendee, speaker, and sponsor, and 3 as an organizer. They are always amazing events. DevOps Days started in Belgium 12 years ago. There have been DevOps Days events every few weeks, ever since, all around the world. In just the next few months, there will be DevOps Days events in Taiwan, Brazil, Colombia, the Netherlands, Poland, Switzerland, and more. As with DevOps Days Seattle, they are all volunteer run by regular folks like you and me. And inclusion is a core tenet of every DevOps Days. We have a strict code of conduct and anti-harassment policy that you've all agreed to when you signed up for this event. If you feel that anyone has breached that in any way, at any level, we hope that you will reach out to the organizers so that we can address the issue as quickly as possible. You can learn more about the anti-harassment policy and code of conduct on the event's website, and you can find the organizers and volunteers in the Discord. So let's get started with our amazing keynote. Emily Freeman is a technologist and storyteller who helps engineering teams improve their velocity because the biggest challenges facing engineering aren't technical, but human. Now, her bio says that she is widely recognized as a thoughtful, entertaining, and professional keynote speaker. I am sure we'd all like to say that in our own bios, but after meeting her many times at events over the years, I can assure you that this is absolutely true. Please welcome Emily Freeman.
autonomy to be industrious on the battlefield. Instead, they were expected to simply execute orders exactly as stated. And the cost of that approach was steep. Within 24 hours, the French had killed 10,000 men and taken 15,000 prisoners on top of that. Napoleon's approach was novel, especially at a time where the term officer meant nobleman. There was the gentry and everyone else, the nobles and the farmers, the chosen, and the rest of us. Napoleon changed all that, but not nearly as dramatically as a collection of colonies in the New World. Within American military circles, there is lore about the controlled chaos of American troops in the battlefield, especially during the Second World War. A Russian document stated, one of the serious problems in planning against American doctrine is that the Americans do not read their manuals, nor do they feel any obligation to follow their own doctrine. A Nazi officer reflected, the reason that the American army does so well in wartime is that war is chaos, and the American army practices chaos on a daily basis. Now, the American response to this is generally, well, if we don't know what we're doing, they can't either. And honestly, I can't think of anything more American. Now, our work isn't exactly war. At least it shouldn't be. If your boss is behaving like a dictator, we should definitely talk about that and get you a new job. But I believe tech, in its relatively young state as an industry, has an incredible amount to learn from older disciplines. American tactics aren't exactly chaos. There is a sort of order, but these actions often do confound the enemy. They don't understand it because the context in which they operate is fundamentally different. The reason that our old world enemies considered our method to be chaos is interesting because it's not quite chaos, but it's something they just didn't understand. America has eschewed all forms of feudalism and imperialism, even as a British colony. Save for a few governors living large in London and a handful of short-lived, honest customs agents, colonial Americans could probably best be described as a band of smugglers. In the mid-1700s, a Philadelphia merchant named John Kidd estimated that out of 400 chests of tea that had come into Philadelphia, only 16 had arrived legally. 16! That's naughty. Americans have always had this sort of Wild West mentality, making our own rules, for better or for worse. And our military reflects this ethos by embracing a dilation of authority. Rather than every single person taking orders in a very strict hierarchy, our army instead chunks autonomy. Everyone from a general to a private exists in a parameterized hierarchy. They answer to a commanding officer, but they have room to be creative. As long as they operate within a set boundary of rules, they're free to operate how they see fit, make their own decisions, get a little weird. I'm Emily Freeman. I'm the author of DevOps for Dummies, and I am obsessed with helping engineering organizations create cultures in which diverse, collaborative teams can thrive. You can snag a copy of DevOps for Dummies on Amazon. I would love to hear what you think about it. This need for distributed thinking didn't stop in the 20th century. In fact, I think it's extremely relevant to our work as developers and operations engineers. Now, if you know me, you know that I live and breathe DevOps. I love it. But I actually want to talk about what's next for DevOps and how we continue to evolve our thinking around engineering culture. You may think software has nothing in common with Prussian commanders, but I beg to differ. As a quick review, software was originally developed linearly and shipped, literally, via the postal service to customers. Remember when the internet came in the mail on a CD? That was fun. It was great. Developing software was a lengthy process. Often years passed between the planning phase and the deployment phase. Now, you may think of waterfall as archaic and an abandoned methodology, but it's not quite completely in our past. While you can update software in satellites and spacecraft, you're probably going to want to get things right the first time, at least most of it, Failing forward gets a lot scarier when you're in an actual vacuum. Waterfall worked, but it was clunky. And like the Prussians, it left no room for adjustment or rethinking strategy on the fly. Then came Agile. In 2001, 17 software engineers met and published the Manifesto for Agile Software Development. This new workflow was a response to the frustration and inflexibility of teams working in a waterfall process. Working within these Agile principles, engineers weren't required to adhere to original requirements or follow a linear development workflow in which each team hands off work to the next. Instead, they're capable of adapting to the ever-changing needs of the business or the market, and sometimes even the changing tools and technology. Agile was the first methodology to really center the customer. It focused on delivering working software frequently and ensuring that the software provided value to the customer. Was it useful? This meant that changing requirements were welcomed, and engineers were expected to communicate with business stakeholders on a regular basis. Now, that never happened in Waterfall. Developers would be handed a binder of requirements from the business and were expected to implement them precisely as planned. Agile was the first time engineering teams really sat down to reflect on their performance and efficacy, what we think of now as retros or post-incident reviews. Although Agile revolutionized software development in so many ways, it failed to address this conflict between developers and operations specialists. It was an incredible step forward, but engineering teams continued to struggle with silos around technical skill sets and specialties. Now, at the time, most teams were organized by grouping developers and operations engineers separately. Developers would write the code and then toss it to engineers or operations engineers to deploy. Now, this created what's referred to as the wall of confusion. Developers had little to no understanding of infrastructure or how their applications actually reached the end user. And operations engineers had little to no understanding of the application code. That lack of awareness and collaboration is what DevOps aimed to solve. And I think we got pretty damn close. I define DevOps as an engineering culture of collaboration, ownership, and learning, with the purpose of accelerating the software development lifecycle from ideation to production. DevOps focuses on people, process, and tooling in that order. And the tenets of DevOps can best be summarized by a model called CALMS. Culture, how your team communicates and works with each other. Automation, how do you remove toil and reactive work by automating it? Lean, how agile or scrappy is your team at providing value to your customers? Measurement, how your team measures its success and effectiveness. And sharing, does your team freely share responsibility, ownership, successes, and failures? In DevOps, everyone that contributes to the delivered product respects each other's contributions and is aware of the motivations and constraints of other teams. And all of these people prioritize the customer over all else. In other words, how can we as a team best deliver high quality software to our users? The issue is that DevOps has become a catch-all term. Not only does DevOps mean 5,000 different things to 5,000 different people, we've added ideas to it. DevSecOps, MLOps, GitOps, AIOps, Biz DevOps, DevDataOps, what? Like tagging things onto DevOps does not make it more DevOps. Honestly, I don't even know what the difference between some of these things are. I believe DevOps really has fundamentally changed our industry, and I'm proud of the work that we've done. We work more as teams. We've reduced silos. We think systematically, holistically. We've sometimes embraced failure. And we are much better communicators across the full process of delivering software. But our industry has fundamentally changed over the last decade. We used to go into offices. I mean, I wouldn't have been able to have the career I have living in Denver 10 years ago. I would have had to move to Seattle or San Francisco, but I get to work from my basement or my yard, sometimes my hammock, because companies have shifted to a remote first culture. That's amazing. In order to stay competitive, and often due to COVID restrictions, even the most office-centric companies have had to rethink their hiring. And I love that. So keep up the pressure. We've moved from monolithic architecture to a microservice architecture, where services are isolated from each other and communicate via APIs. Our applications are distributed on infrastructure across the globe to be geographically closer to our customers and reduce latency, or the time between when a user makes a request and your application actually responds. Our technical environment, tooling ecosystem, culture, it no longer fits into the original conditions in which DevOps was created. Now, when I first pitched this idea to a friend, I was met with some pushback. People are still adopting DevOps. People still aren't sure what DevOps is. Large enterprises and government agencies are still sorting out the details of adopting DevOps. Of course, I wrote DevOps for Dummies less than 2 years ago. I am not prepared to scrap DevOps and toss out anyone who isn't living on the cutting edge of tech. This is the technology adoption lifecycle, created by researchers Beal and Bolin in 1957. And a version of it was popularized more recently by Jeffrey Moore in his book, Crossing the Chasm. Here's the thing. Yes, companies and organizations, even people, are still adopting and implementing DevOps because it's valuable. And the ideas and practices that DevOps embodies have incredible potential to improve collaboration, reduce silos, help engineering teams deliver more resilient applications faster. But I don't want to wait until the very last person in tech decides to get on the DevOps train to start thinking about what's next. Continuous improvement doesn't just apply to our systems. It applies to us too. We know that to stay relevant and honestly employed in tech, we have to constantly learn new skills, new tools, understand new frameworks. That's part of our job. That same learning culture applies to how we think about our people systems as much as it does our software. Now, confession, I would love to be able to tell the future. That would be very, very handy. But I am not a future or fortune teller. And I truly despise the term futurist. I think it's very silly. I'm not completely certain what the next phase looks like. But I have some ideas that I want to pitch you that can get the conversation started. Every country across the globe has a way of war, a unique style, a grouping of tactics unique to their culture, thinking, and priorities. Individual losses are not something acceptable by Americans. Our culture puts an extreme emphasis on the individual, and the outcomes of that are a mixed bag, as we can tell. But that's the way we are. And the military is no exception. We must win every time because the cost of life is simply too high to accept. Therefore, we over-index on investing in training and technology to leave troops over-prepared for battle. This extreme focus on training builds trust bidirectionally across the entire hierarchy. And this is critical to American hard power. Leaders have trust in their subordinates because they've seen them in action over and over and over again. Which means when a sergeant is asked to clear a building, their commanding officers know that they will be successful. And soldiers, when asked to accomplish a mission, know that they're not being haphazardly sent to their death. This type of unwavering trust is unique to only a handful of militaries, seen almost exclusively in the Five Eyes countries: Australia, Canada, New Zealand, United Kingdom, and the United States. But it's trust that allows our soldiers to put all their brain power into the moment, into the mission. Across every branch, every division, every specialty, there are three main tasks everyone focuses on: shoot, move, communicate. Shoot, move, communicate. It's built into everything, repeated ad nauseum. This means budget goes to three areas: weaponry, transportation, and comms. With communication, I think, really being that linchpin. The other two can't happen without real-time, accurate communication across units. Now, you and I don't typically get shot at, nor do we live in retrofitted shipping containers, thank the Lord. But I do reckon that we should focus on three things too: shipping, iterating, communicating. repeating. What's the point of all of this if we're not delivering working software to our users on a regular basis, listening to them, thinking about the user experience? And once we get that feedback, the process begins again. We iterate, we adjust the roadmap, we prepare our infrastructure, we ship. But we have to do all of this in a distributed fashion, which means we have to think about this a little differently. I think we should take our cues from the bodies in which we sit right now. DNA contains the blueprints of how to make a human body. Well, any body, but in our case, human. With the exception of brain cells that rearrange their DNA over time, it's actually really fascinating, worth a Google search. Almost every cell in our body contains the same blueprint. But in utero, our liver cells know to become livers and heart cells to become hearts and so on and so forth. Differential or selective expression of genes is determined by genetic switches referred to as epigenetic markers. These markers turn genes on or off like a light switch, kind of like a feature flag. And they're influenced by hereditary factors, diet, the environment. In a complex software system, I would consider these influential factors to be code, inputs or variables, and the environment, your operating system, database, infrastructure, etc. All of these systems, from the military to our bodies to our applications, are simply too big to manage from a single point of view. There is no way to think of it as one unit. Instead, I believe we have to break it up into smaller components, supply those teams with the tools they need, practice constantly, and trust that everyone will make the best decisions possible in the moment. One of the unintended consequences of DevOps has been this pressure or belief that everyone has to do everything, that a JavaScript developer has to understand the intricacies of the application CI/CD pipeline or the details of the cloud infrastructure. And on the other side of that coin, there's an extreme focus on developers lately that's left operations engineers feeling somewhat ignored, unsure of their role. DevOps is not a methodology that encourages everyone to do everything. That is asinine. We all have specialties, and we should lean into our personal strengths and professional strengths, leaning on others in our team to buttress our weaknesses. Calms define DevOps in so many ways by establishing tenets of focus: culture, automation, lean, measurement, sharing. Building on top of DevOps and Calms, I'd like to pitch SOAR: swift, observable, accountable, and resilient. The first principle is swift. Everything needs to be moving forward at all times. There's a flow to software development. And the trick is to think of it like water. Keep the water moving and keep it moving fast. This doesn't mean rush, nor does it mean to get sloppy. There's a saying in the Navy SEALs that slow is smooth, smooth is fast. So look for small improvements. This is where your measurements and data become truly critical. You must have a baseline on which you can compare to see improvement. Otherwise, this whole thing will be futile. Have you ever sat through an entire day of meetings and at the end of the day thought, what did I even do today? I didn't accomplish a single thing at all. You did, it just doesn't feel that way. And this is the same principle. If you don't have data to support your acceleration, you will not feel it. This is where I think SLOs and SLIs are extremely handy. A service level objective, or SLO, is a goal to describe a specific measure of performance to a particular service. These objectives describe what your team must deliver to ensure the customer is having a good experience with your application. SLOs are informed by service level indicators, or SLIs. This is a small, very detailed sample of a service performance taken at a very specific time. Optimize your goals to be clear, concise, simple. A great SLO would be something like, this service's response time will be under 10 or 100 milliseconds, 99.95% of the time, or an error rate under 2%. The issue with any complex system is you can't freeze it and study it holistically. As soon as you look at it, it's different because time doesn't stop for any of us. And from 1 second to the next, your system is different. What we can do is take samples of our system and study those to determine with confidence the state of the whole system. Our bodies are even more complex than our socio-technical systems. And lab tests are a great example of sampling. If you have blood taken or your throat swabbed, a sample of cells is removed and studied, giving us insights into the health of the whole body. For us, SLIs are like those samples, tracked constantly to give us confidence in the health of the system. Part of being swift is removing blockers and bottlenecks across your team. A bottleneck is congestion or a blockage across a process. These are commonly approval processes, manual tasks. For example, a mandated manager approval or manual build or deployment process. Any handoff between teams can also quickly become a bottleneck as some engineers are consistently dependent on others to continue their own work. One of the trade-offs we made when we moved to a distributed cloud-based architecture is we lost some visibility. We moved everything to the cloud and there was this handoff of responsibility, which was awesome. Yes, we have to configure and optimize the infrastructure, but it's not like we need to maintain actual servers anymore or stress about environmental factors impacting storage and compute. That's someone else's problem. But that handoff of responsibility, we lost some observability in that, how things were actually running. It went into a bit of a black box, and that's mildly scary. Building on the measurements you use to implement a swift delivery of software, you'll want to gain as much useful telemetry as possible into your system. Now, this doesn't mean we can track every single little thing. We've always had to make these decisions, choosing what information to store in our logs versus what to let go, what behavior should trigger alerts versus what shouldn't. This isn't new, but these aren't decisions that humans should have to make on a daily basis anymore, which is why I think AI ML is particularly interesting in this area. How can we train our systems to self-diagnose and alert us to issues or areas of concern before there's ever a user impacting incident? AppDynamics conducted a survey on AI ops in 2018 and found that 91% of enterprise companies reported siloed performance monitoring. In other words, service teams only tracked impacts to their particular area of responsibility. Now, that's not very DevOps. I hope it's improved over the last few years, but I'm doubting it has. We know that even in distributed systems, nothing is ever fully decoupled. And the intricate behavior of the system requires holistic monitoring, something machines are pretty good at if they're trained. Now, imagine being alerted that your load balancer isn't behaving correctly before a single server falls over, or knowing with confidence which services in your application to focus on and optimize because they contain the most transactions or the most impact on revenue. Finally, everyone in your organization needs access and training to these resources. They should not be reserved for only some engineers. So prioritize autonomy, chunk responsibility, enable your team to solve problems early and independently. I prefer the word accountable over responsible. Accountability is a willingness to account for your actions, whereas responsibility implies a level of control over a situation or a duty to deal with an issue. As a mom, I am responsible for keeping my child alive by providing basic necessities, food, shelter, clothing, etc. But the higher order role I have is to love her, to model the principles I value, to train her to be self-sufficient, independent, a functioning human. And that's where I'm accountable to my daughter. I make decisions daily and I never really know if I'm choosing correctly. But I do know the information I used to make the decision and how I came to the conclusion I did. And when she's older, I'll be able to account for my decisions. And even in the cases where I'll have chosen incorrectly, I have confidence that I made the best choice I could given the data I had at the time. That's all we can do. And it's that concept that I think is a critical differentiator in reflecting on performance and incident response. We can say blameless until we're blue in the face, but it's an instinct of humans to throw someone else under the bus when we're stressed. That lizard brain back here, it has one job, and that's to keep you alive at all costs. When you feel fear, that gets triggered, and there's no way to unwind that adrenaline response. But I think if we shift the conversation from responsibility over an incident to accountability, it reframes the entire conversation. This accountability extends to your role as well, and that you're accountable for having an awareness and a respect of the work of your peers. You don't have to ever write a line of JavaScript to appreciate the language's capabilities and the choices that developers have to make. It's this awareness and respect that enables everyone to come together to the table as equals and contribute to the delivery of great applications. The final tenet is resiliency. I like to think of this as grit. I've always said that my greatest advantage is that I can take more hits and still get up than the average person. I've seen some stuff, and I've learned that the only path forward when you get knocked down is just to get back up. You don't have to pop up like an overcaffeinated gopher or meerkat. You can take your time, but you have to stay in the game. You can't lose as long as you're in the game. So just keep moving forward, even if forward is a snail's pace. We've talked about resiliency from a technical perspective for years: mitigating disaster, practicing failure, chaos engineering, fault injection, ensuring services can recover quickly, accurately after an incident. But for me, I think the resiliency of a team is a fascinating topic. What causes one team to recover from stress while another collapses? Perhaps what's most fascinating about this is that the stimulus, the actual stress, it doesn't have to be big to be observable. Take two teams who receive free lunch at work, or used to. Tell them that free lunch is over. No more Taco Tuesday. It's done. Now, one team collapses into a frenzy of complaints, extrapolating the end of lunch to things like, will there be layoffs? Do you not value us anymore? Other companies are still offering free lunch. Are you going to adjust my salary to make up for this loss of compensation? This team ruminates on this, and it has no ability to mourn and then move on, to recover. The other team has a momentary adjustment, as is natural, but realizes that they can use the time to instead explore their city with their colleagues by organizing lunches several times a week. Same stimulus, vastly different reactions. I believe it comes down to psychological safety and group power dynamics. In order to build a resilient team, you must first grant people autonomy and trust. You have to train them to not only do their work better as individuals, but to do it better as a team. Practice may not make perfect, but it sure does make better. And I think some managers hear psychological safety and think they have to treat their teams with kid gloves. That's not true. Hard conversations around performance and expectations are part of the dynamic between a manager and a team. But you have to communicate expectations clearly if you're going to hold someone accountable. And you have to communicate your appreciation of their work just as clearly, perhaps more. People need to know that they're valued, that they have room to grow, someone has their back, and that they're safe. These are the characteristics of resilient teams and should be fundamental to your daily practice. In a distributed socio-technical system, you have to think of DevOps like DNA. Each component in your system, especially the human components, are like cells with epigenetic markers. They each carry all the information they need to implement DevOps: the trust, training, authority, autonomy, tools, but they can pick and choose what aspects of it best suit their unique circumstances at any given moment. Now, there's some nuance to this. I'm not saying that you get to toss key tenets of DevOps away just because they're hard. But what I am saying is that you can lean on the aspects of it that fit your immediate needs while maintaining an awareness, a respect of the people around you who work in different areas. I believe if we move to this distributed approach, we will build teams capable of delivering better software faster and more reliably. I think the next 10 years are going to be fascinating. I can't tell you exactly how it's going to turn out, but I have an idea of where we should start. And I'm going to focus on doing the next best thing. Our approaches and architectures and priorities continue to shift like sand, but through all of that change, I believe we're building something truly amazing. And I'm thrilled to be with you as we build it. Thank you so much.
Hi, I'm Tim Davis, DevOps advocate with M0. I'd like to start off by thanking everybody with DevOps Days Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away. And hopefully everybody has a great time. Take care.
The challenge with building modern apps is that they require modern building blocks like cloud-native practices, containers, microservices, and Kubernetes. It's a lot to consider. What you need is a full-stack platform for building modern apps. Tanzu Advanced simplifies and secures the container lifecycle, accelerating the delivery of modern applications at scale. Developers get a self-service experience with less toil, while ops can manage modern applications securely and more effectively. The result will be happier customers and the competitive advantage you've been looking for. Check out our website to learn more about Tanzu Advanced or any of the other Tanzu editions that are designed to meet you wherever you are on your app modernization journey.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra DAS free to see how OPA can policy enable your cloud-native stack today.
Bridgecrew's developer-first platform is designed to find, fix, and prevent cloud security misconfigurations. With hundreds of built-in policies and native workflow integrations, Bridgecrew helps enforce security best practices across the development lifecycle. Leverage Bridgecrew's VS Code extension to get real-time feedback as you write Terraform, CloudFormation, Kubernetes, serverless, and other infrastructure as code configurations. Scan IAC files and directories before committing code to shared repositories with Bridgecrew CLI. Address misconfigurations continuously on each code change with Bridgecrew's native source control and CI/CD integrations. Bridgecrew also provides security as code fixes back into your workflow to prevent misconfigurations from being deployed. And if drifts occur in running resources and workloads, Bridgecrew detects them, alerts you, and provides automated remediations. With complete code to cloud visibility, you can be secure and compliant without slowing down. Get started with codified cloud security for free at bridgecrew.io.
Hi, I'm Chuck Norris, and I'm here to explain what the heck incident management is. Picture this. It's Friday at 5 p.m. You hear it, the dreaded page. The server is down. Customers can't log in. Somebody dropped your database. Now what?
Well, Chuck, everything from this point on is incident management. Now you have to remember what the process is, who to call, when to update the status page,
and all of that manual work that no one wants to do on Friday at 5 p.m. Particularly me.
Not to worry though, we built Fire Hydrant to handle all of this, from declaring an incident either from a page to declaring it via our API or from Slack. From tracking, communicating, retrospective, all the way through, we have built Fire Hydrant to handle all of it. So that helps you get back to resolution quickly and back to your weekend.
When I deployed Lacework, I was able to detect things like, is somebody running Netcat on a machine? Is somebody sudoing and running something that they shouldn't be? I could use it to audit if there were a failure. I could see, well, what happened on this machine and who did what? And it's not to go and point a finger at a particular person and say you've done bad, but it's more to empower them and to tell them how they can do better. I've been very happy with Lacework. I've been a customer for about 2 years at Turnitin, and I'm going to continue to be a customer. They continue to excel as one of the experts in their space.
Hello everyone, Austin Becker, Solutions Architect here at Sonatype. Modern developers leverage open source software to accelerate getting applications to market. The dilemma developers face is selecting which components to choose. Some have efficient tools to guide them in their selection, while others waste manual time researching these components. Sonatype's best-of-breed platform empowers developers to select the correct components that are non-vulnerable and also enforces security and legal policies throughout the software development lifecycle. This allows companies to align their security, development, and legal teams to more efficiently and securely get applications to market. Thank you.
Hello DevOpsDays Seattle. My name is Raf Bocino and I'm here to introduce you to SkyCrafters. SkyCrafters is an inclusive community where novice and seasoned cloud practitioners can find information and answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to SkyCrafters.
Hi, I'm Tim Davis, DevOps Advocate with M0. I'd like to start off by thanking everybody with DevOpsDays Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away. And hopefully everybody has a great time. Take care.
The challenge with building modern apps is that they require modern building blocks, like cloud-native practices, containers, microservices, and Kubernetes. It's a lot to consider. What you need is a full-stack platform for building modern apps. Tanzu Advanced simplifies and secures the container lifecycle, accelerating the delivery of modern applications at scale. Developers get a self-service experience with less toil, while ops can manage modern applications securely and more effectively. The result will be happier customers and the competitive advantage you've been looking for. Check out our website to learn more about Tanzu Advanced or any of the other Tanzu editions that are designed to meet you wherever you are on your app modernization journey.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra DAS free to see how OPA can policy enable your cloud-native stack today.
Bridgecrew's developer-first platform is designed to find, fix, and prevent cloud security misconfigurations. With hundreds of built-in policies and native workflow integrations, Bridgecrew helps enforce security best practices across the development lifecycle. Leverage Bridgecrew's VS Code extension to get real-time feedback as you write Terraform, CloudFormation, Kubernetes, serverless, and other infrastructure as code configurations. Scan IAC files and directories before committing code to shared repositories with Bridgecrew CLI. Address misconfigurations continuously on each code change with Bridgecrew's native source control and CI/CD integrations. Bridgecrew also provides security as code fixes back into your workflow to prevent misconfigurations from being deployed. And if drifts occur in running resources and workloads, Bridgecrew detects them, alerts you, and provides automated remediations. With complete code to cloud visibility, you can be secure and compliant without slowing down. Get started with codified cloud security for free at bridgecrew.io.
Hi, I'm Chuck Norris, and I'm here to explain what the heck incident management is. Picture this. It's Friday at 5 p.m. You hear it, the dreaded page. The server is down. Customers can't log in. Somebody dropped your database. Now what?
Well, Chuck, everything from this point on is incident management. Now you have to remember what the process is, who to call, when to update the status page,
and all of that manual work that no one wants to do on Friday at 5 p.m. Particularly me.
Not to worry though, we built Fire Hydrant to handle all of this. From declaring an incident either from a page to declaring it via our API or from Slack. From tracking, communicating, retrospective, all the way through, we have built Fire Hydrant to handle all of it. So that helps you get back to resolution quickly and back to your weekend.
When I deployed Lacework, I was able to detect things like, is somebody running Netcat on a machine? Is somebody sudoing and running something that they shouldn't be? I could use it to audit if there were a failure. I could see, well, what happened on this machine and who did what? And it's not to go and point a finger at a particular person and say you've done bad, but it's more to empower them and to tell them how they can do better. I've been very happy with Lacework. I've been a customer for about 2 years at Turnitin, and I'm going to continue to be a customer. They continue to excel as one of the experts in their space.
Hello everyone, Austin Becker, Solutions Architect here at Sonatype. Modern developers leverage open source software to accelerate getting applications to market. The dilemma developers face is selecting which components to choose. Some have efficient tools to guide them in their selection, while others waste manual time researching these components. Sonatype's best-of-breed platform empowers developers to select the correct components that are non-vulnerable and also enforces security and legal policies throughout the software development lifecycle. This allows companies to align their security, development, and legal teams to more efficiently and securely get applications to market. Thank you.
Hello DevOpsDays Seattle. My name is Raf Bocino, and I'm here to introduce you to SkyCrafters. SkyCrafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to SkyCrafters.
Hi, I'm Tim Davis, DevOps Advocate with M0. I'd like to start off by thanking everybody with DevOpsDays Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you.
Welcome back. That was great. Thanks, Emily, for the Thanks, Emily, for the great talk and discussion afterwards. I'm sure we're all looking forward to that ebook that you mentioned in the chat coming soon about public speaking. So that brings us to the next speaker, Jeremy Meese. Jeremy is head of DevRel at Circle CI. They're in a pretty special position of running continuous integration for 25,000 orgs. As a result, they have a great view into how a lot of different companies implement their DevOps practices. Let's listen to Jeremy discuss their latest report on DevOps in the context of COVID. Jeremy?
Hi, I'm Jeremy, and we're going to be talking about DevOps and software delivery in a global pandemic and what we can learn about better DevOps practices. So before I get get too far into this, I want to call out the immensely important State of DevOps reports. These are highly valuable and have helped to drive the important practices and behavior shifts in the industry that we've seen over the years. The big difference between our report that we're creating each year now and these other reports is that the industry reports are largely based on survey data and based on and potentially biased by the memory of the engineers who are taking the survey who chose to participate. Often when taking surveys, we kind of fall into the trap that John Allspaw once tweeted a few years back of work as imagined versus work as done, or as we're calling it, performance described versus performance derived. Given that our platform is used to perform many of the activities associated with high performance teams, it allows us to kind of measure the actual behaviors being performed to get a better understanding of how actual engineering work gets pushed through the pipeline. Like, did they actually push the code as often as they claim they did today? And how long are their workflows actually taking? So, as I said, my name is Jeremy Meese, and I'm the Director of DevRel and Community at CircleCI. We're a continuous integration and continuous delivery company. You can follow me on the Twitters at I am Jerdog. So, at CircleCI, we have this massive amounts of unique data on how technology delivery teams behave in the wild. This report examines over 55 million data points from more than 44,000 organizations and 160,000 projects, which makes it pretty much larger than any other survey by far. We started looking at all this data in 2019, figuring out how we could kind of slice and dice it up. And then in this last year, with the whole world kind of changing, we really wanted to see what had changed in the data with how developers were working. We don't believe in this one-size-fits-all success metrics for delivery. Every team is different. And so, however, the software delivery patterns we've observed on our platform, especially the data points from top delivery teams, show some key similarities that suggest valuable benchmarks for teams to use as goals. So one of the big things that we offer was kind of a set of baselines for the 4 metrics related to CI that we think are most important for developer teams to track as far as measuring velocity and engineering efficiency on their teams. These would differ slightly from the 4 classic metrics of deployment frequency that we kind of see here. So deployment frequency, lead time to change failure rate, recovery from failure time. So those are kind of the traditional classic metrics. But for us, we kind of identified these benchmarks for high performing continuous integration, continuous delivery benchmarks for high performance. Yeah. So those would be duration, which, less than 10 minutes, throughput, being, at will as often as you can, mean time to recovery, being, less than an hour, and success rate being more than 90%. So let's go ahead and jump right into the data. Throughput. So originally we thought about this as, how often are you committing? How often are you, pushing your code? But then we realized that commits can sometimes be grouped and pushed into, continuous integration systems at once and not always running all at the same time. We see that most projects are set to basically run their CI per push to the Git server. And so some do it on a schedule, but most usually push it to the Git server. So looking at the data between 2020 and 2019, at the 50th percentile, people are triggering CI about 0.7 times per day, which isn't a lot and is a slight dip from 2019. But at this 95th percentile, you're getting a lot of increased activity at roughly 32 times a day. The mean, though, kind of shows that projects are primarily sitting at 8 times per day versus just under 6 per day in 2019. What we found here is that most projects just aren't really deploying dozens of times per day. They're not even validating their software dozens of times a day. And so while it's not untrue that a description of a high-performing team is one that deploys a lot of projects, it just means that it may be one project that's moving that fast, but a whole bunch of other projects that they have really aren't moving as quickly. Looking at the total sample of everything going on within an engineering department versus maybe just their primary thing, kind of helps us to see this. So duration. What we see in the 2020 data is that 5% of builds finished in less than 12 seconds, which when you think about 5%, that doesn't sound like very much, but we're looking at like 500,000 builds in that sample. And that's not a small number, which then kind of begs that question of like, what can you get done in 12 seconds? And the answer is probably not a lot, but some people can do quite a bit in that 12 seconds. If you have many unit tests that can be parallelized, or maybe you can run a whole unit test suite in that time, or if you're uploading an artifact into an S3 bucket to get it ready for deployment, you can probably do that in less than 12 seconds. For 2020, the 50th percentile pegs at about around the 4-minute mark. And as a developer, if you're getting good quality feedback in 4 minutes, that can be a game changer for sure. Now, the 95th percentile is sitting at 34 minutes. And for a lot of companies, depending on what's being built, what your test scenarios are, and how thorough all of that is, that 34-minute mark is a good place to be. But what we're seeing is that half of all builds are still finishing in about 4 minutes. Comparing that to 2019, we're not seeing a lot of movement there, with the durations going up just a tiny bit, usually indicating a bit more testing is happening as we've seen on the platform. So success rate. As we look at success rate, we're looking at how often does your pipeline complete with a green status. A pipeline can complete with either red, green, or error. And error here just means incomplete. Something couldn't be done. It could be that an external resource was not reachable, or you were putting an impossible scenario in place, like a test divided by 0, and you blew up the whole thing. I know this by experience. We're going to move on. But for us, for success rates at the 50th percentile, we're seeing 61% of all pipelines are passing in green. When you look at the lower and higher end of those numbers become less meaningful, because there's a group of things that never fail, and there's a group that always fail. So when you throw those out and just look at the middle, you see that roughly half of all builds are passing. What this tells us is that a lot of people are just testing out projects, dabbling with CI. How many of us have started up a project over the weekend, started messing around with building it, and then haven't gone back to that project? Luckily, we're virtual and we can't all see everyone's hands raised. I know I have. Heck, I have over 20 domains sitting there in Namecheap doing nothing. We really didn't see much difference here between 2019 and 2020. So mean time to recovery, the recovery time. So in the 5th percentile, we see 2 minutes that it'll sit in a failure state before it's recovered, which is just under a minute improvement from 2019. A lot of times in those scenarios, that could be from multiple contributions running in parallel, where developer 1 pushes bad commit and developer 2 pushes a good commit. The bad commit fails really quickly, with the good commit succeeding right afterwards, or it could be the same developer. I know I've pushed something and realized quickly what I broke, and I pushed that fix immediately. And we're not even going to go down the rabbit hole of all my commit messages that show that. So at the 50th percentile, you're seeing about an hour until it's recovered properly, an improvement of 3 minutes. And then from there, you start seeing things that are probably more attributed to some code gets pushed, and then you go home and you come back the next day to check it. The mean here at 14.85 hours really kind of illustrates that. It's about the time of the end of a workday to the start of the next. It's the 90th and 95th percentile where it looks like people just kind of go home after they've started the build. We're seeing improvements for the most part, but this going home bit is interesting. It tends to kind of butt up against a classic continuous delivery philosophy that says, like, you can't go home if the build's red. But there's also some pragmatism here that, like, we go about where you're analyzing the build. Is it really the most important? Maybe it's a test build. Is it a feature branch? And we're not going to judge on someone's work habits on going home to come back the next day and check on the build. So overall in 2020, we've seen recovery time definitely decreased, and it's moving in the right direction. We can hypothesize here on this a little bit and say that maybe it's because more people are home and more attentive to what's going on with the code, and there's maybe less stepping away from the office for a cup of coffee or that sort of thing. All right, so what I kind of move into now is kind of looking at the insight we've been able to gather from the last 2 years of reviewing this data and what we can derive from it. In case you didn't know, 2020 has been a year, and it's been a year like no other. We're now, almost a third of the way through 2021, and even looking back, like it's just the last over a year has been crazy, been just wild. We can't look at the data we've seen so far without thinking about the impact of a global pandemic on DevOps and software delivery. How has it affected team performance? And that was what really drove us to dive even deeper into this data with that lens. So with throughput, we have the data from March to May of 2019 on the left, March to May of 2020 in the middle, and then on the right is our August 2020 data. And that's going to be the same for all these graphs going forward here. For many of the percentiles, we saw a slight dip as the pandemic was hitting, and then the maximum was reached in April of 2020. Now, I think this makes sense in the face of global uncertainty, and I feel it's kind of feel it's wise to take our engineering teams and shore up business interests. And in this case, it seems to reflect that teams began automating as much as possible with the entire workforce heading home and companies doing that very thing, shoring up. So there's a lot of that shoring up of core applications as quickly as possible, resolving bug tickets, issues, et cetera, in order to really lean on the stability of the platform or make it stable in some cases. And if you think about what was happening in April of 2020, that was primarily lockdown mode in North America and a lot of Europe, and we saw a whole lot more code going into the system. We also saw a lot more activity happening on the weekends than had previously been happening, along with more hours in a day where CI activities were kind of taking place per project, roughly 14 hours where it had been 11 or 12 previously, which can be reflected in no more commuting times. You're not sitting on a train or in a car traffic on your way home. You're just able to stay at home and finish what you're doing. So with duration, we see the mean falls heading into this pandemic and then stays steady. But the 50th percentile and above, the duration increases year over year with a slight dip in April and then increased again in August towards the longest duration year over year. So kind of what we're thinking here and as we're seeing is that that's indicative of you're shoring up your business in this type of environment, and you're adding more tests to your test suite, to your CI suite, and more fine tuning of your code in your testing. And then in that testing, you're increasing your parallelization or optimizing right away to make sure that the application is as stable as possible. This also holds true as we see throughput also grew around this same time. Success rate. So with success rate in the pandemic, when we look at the 50th percentile, there are some things that are always green and some things that are always red. What we see with this uptake in success rate for 50th and 60th percentile is about the same year over year, though. This tends to show your typical red to green type of cycle as people are kind of testing out new features, innovating, etc. No one expects every single commit to be perfect every single time. So a healthy, innovative engineering team tends to have somewhat a high degree of failure, and that's okay. But when we see things like a peak, kind of hear about the same time kicking into the pandemic, that signals that with the average engineering team, they're likely doing less innovation and more shoring up of the core business, like resolving those tickets and issues, bugs, etc. And when you're resolving bugs, you're going from red to green, you're getting more stability in the system. So we would expect to see a peak in success rate. Then once the business is stable again, the success rate would go back down and you'd see more innovation or new feature branch development happening. Now, the lower bar here, that the red kind of trailing off towards the end of last year, signals to us through the data that people are starting to test out more on automation tools, testing out CI tools, and starting with a handful of commits where they're not likely to be very successful. And we've seen, kind of the other thing here that's interesting about success rate is that success is the state you want to reach. And there are many ways to get to a failed build, but really only one way to succeed. So if you have something that's failing, you could push another commit, it could fail again, and you push another, et cetera, doing that a few more times until you've pushed 5 commits, which all failed. And then the 6th one was the success. So now you're at, a 1 in 6 success rate, which we can see trailing off, here at the bottom on the graph. Success rate can be an interesting statistic that can tell you a lot about how your teams are functioning, but isn't always indicative of bad process or performance. So the kind of hypothesis here that we're kind of working with is that success rates were basically the highest on record throughout April and May. And one thought here around that is that the level of distraction for many developers, like not getting to conferences, no traveling, etc., was removed, and they started working on all the software and core business, ensuring that. Recovery time. What we've seen with recovery time in this data, and follows the same basic path from these other metrics, is that they're declining. In the 95th percentile, we're seeing that year-over-year drop, but a big drop in April and May. And those are generally reflective of that if stability is the business's goal, especially with those commits that you're pushing during this time. With what we saw in the early stage of the pandemic was an all hands on deck mentality and getting to resolve issues as quickly as possible, getting their signal back as quickly as possible, mitigating issues, and so on. And that's that feedback cycle at the heart of CI and rapid app development. Everyone wants to see a decrease in recovery time, but you see signals like we have in this plot here that come from the ability to bring everyone together and focus back on the core business and shore things up with the uncertainty of early COVID times. So the hypothesis here is, would tend to really show that we had more developers pushing code, fixing issues, and they had less distractions like conferences, travel, etc. Everyone's back on trying to get to the stability state that's important to the business. I do, though, want to stress that just because you're at home and not having distractions from your coworkers, that doesn't mean there aren't distractions at home. And I think that's an important distinction here. There are plenty of distractions at home, and it's important to take that time for yourself. But what the data is shown is that some people were able to do more well at home, others were able to do less. All right, so kind of the fun little spot now is kind of looking at the things that kind of make you go, So, with branch info, we're in an interesting position to be able to see how people are actually using their branches in development. During the pandemic, especially June through July of last year, and even continuing now, as the social unrest and Black Lives Matter protests rightfully exploded onto center stage and need to stay there. And part of that was a resurgence of an older discussion about, in the tech world, about the term master and slave throughout tech industry and the important quest to find better language that's more inclusive. So we took the data and we kind of asked our data scientists to see what they could find if the use of master as a branch name decreased year over year. We, of course, saw a lot of press around this and online petitions and discussions on Twitter and companies committing to doing so. And GitHub, came and published how they were going to change the default branch to main instead of master. And so I can say that realistically, we've seen almost no real decline in the use of master as a branch name yet. Now, while I think this is sad that the data hasn't really reflected it, I think we're seeing more and more tooling default to better naming conventions. So I believe that we'll see more of this in the near future. In some companies, especially with a lot of technical debt and large, repositories and whatnot, it's hard to just make such a big change, but we are seeing that start to change. And I think that's important. Success rate. Another thing we noticed was that, there was a difference in success rate between branches, with the default branch being higher than on non-default or feature branches. We saw that the success rate is 80% on default branches at the 50th percentile and 100% for the 75th percentile and above. What this is telling us is that a lot of the innovation is happening on feature branches, with 58% success rate for non-default branches at the 50th percentile. Once things were, more successful, then those they were moved to the default branches, and the success rate went up. Duration on the default. We saw that the duration on default branches was faster at every percentile over non-default branches. So this tells us that the mainline branch people work on test engineering, working on making it fast, making sure that the feedback is good, and continuing to iterate. Recovery time was lower on the default branches at every single percentile, meaning that people who are relying on mainline, they're watching the recovery time a whole lot more to make sure that fewer people are impacted by a red build. All right, so final little bit here is kind of looking at what are some of the development practices that we saw that really what we would say definitively work. Success rate does not correlate with company size. So when you look at organizations and how many contributors are in that organization, if you have 800 contributors in your GitHub org, or you have 4, we can't really tell that just by looking at success rate. It doesn't matter how, it's not a one-to-one thing that, larger the company, the more success rate. Duration. Another thing we've seen is that duration is longest for teams of 1, which I think makes sense because if you're a team of 1, you really aren't a team. But secondly, you might not care if it takes you a long time to get feedback because there's no one else waiting on you. And I think there's a kind of a social construct here that when you know that you're in the way of somebody else, you will do extra work to make sure that it's faster or better understood or better take care of it in a better way. And those are some of the things that we miss when it's just you. So recovery time decreases with the increased size of your team, which we found played out up to about 200. Above that, the data is a bit fuzzy since we don't see a lot of data with large teams over 200 all at once in that same repo. They might be spread out across all the different repos in an organization. So basically, the more people you're impacting with a red build, probably the faster you are to recover it. When things are red, you're holding up a lot of other devs in their work. You get Slack messages wondering why it's still in red. So the incentive is to get things resolved and back to a green build quickly. Performance is better with more than one contributor. I feel like that's something that we should make sense in that it is every outcome we could measure showed that you're better with you, and if you have more people you're working with on X thing, you're going to be performance is going to be better. And kind of the takeaway here around software is collaborative is that software really is. This isn't new, but we don't talk about it enough, I don't think. When we talk about data and metrics, this is a thing that we're able to kind of really prove out in our data here, is that when you look at the outcomes and success rates of teams, team sizes and number of contributors that you have, you can see that putting more people working on a project is going to give you better outcomes. Seems to kind of follow. The last one here is don't deploy on Friday is not a thing. We see, on Twitter every once in a while, you see the whole don't deploy on Friday, and the trend goes up, people start talking about it, and then it fades away. We kind of looked at the data because we had the massive data set, and we noticed that 70% less throughput on weekends, and there was 11% less throughput on Friday. And we looked at this from a UTC perspective, and then 9% less throughput on Monday, also UTC. So we could kind of standardize the time and look at it over a 24-hour period. What this showed was that people are still deploying. Yeah, maybe it's a little less on Friday, but primarily don't deploy on Friday is not a thing. And I'm sure that will spark some controversy, and I'm here for it. All right, so the last thing here, if you want to see the full report, which really dives a lot deeper, it's probably more interesting reading it than hearing me talk about it. You can find it, scan this QR code. The slides will be available. And then you can go to circles.ci/SSD2020, which is State of Software Delivery 2020. And you can get the full report there. You don't have to sign up for anything. You can just get the free full report. And thank you. I appreciate you coming to the talk.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra as free to see how OPA can policy enable your cloud-native stack today.
Hello, DevOpsDays Seattle. My name is Raf Bocino, and I'm here to introduce you to Sky Crafters. Sky Crafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to Skycrafter.
Hi, I'm Tim Davis, DevOps advocate with M0. I'd like to start off by thanking everybody with DevOpsDays Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away. And hopefully everybody has a great time. Take care.
The challenge with building modern apps is that they require modern building blocks like cloud-native practices, containers, microservices, and Kubernetes. It's a lot to consider. What you need is a full-stack platform for building modern apps. Tanzu Advanced simplifies and secures the container lifecycle, accelerating the delivery of modern applications at scale. Developers get a self-service experience with less toil, while ops can manage modern applications securely and more effectively. The result will be happier customers and the competitive advantage you've been looking for. Check out our website to learn more about Tanzu Advanced or any of the other Tanzu editions that are designed to meet you wherever you are on your app modernization journey.
Hello everyone, Austin Becker, Solutions Architect here at Sonatype. Modern developers leverage open source software to accelerate getting applications to market. The dilemma developers face is selecting which components to choose. Some have efficient tools to guide them in their selection, while others waste manual time researching these components. Sonatype's best-of-breed platform empowers developers to select the correct components that are non-vulnerable and also enforces security and legal policies throughout the software development lifecycle. This allows companies to align their security, development, and legal teams to more efficiently and securely get applications to market. Thank you.
Bridgecrew's developer-first platform is designed to find, fix, and prevent cloud security misconfigurations. With hundreds of built-in policies and native workflow integrations, Bridgecrew helps enforce security best practices across the development lifecycle. Leverage Bridgecrew's VS Code extension to get real-time feedback as you write Terraform, CloudFormation, Kubernetes, serverless, and other infrastructure as code configurations. Scan IAC files and directories before committing code to shared repositories with Bridgecrew CLI. Address misconfigurations continuously on each code change with Bridgecrew's native source control and CI/CD integrations. Bridgecrew also provides security as code fixes back into your workflow to prevent misconfigurations from being deployed. And if drifts occur in running resources and workloads, Bridgecrew detects them, alerts you, and provides automated remediations. With complete code to cloud visibility, you can be secure and compliant without slowing down. Get started with codified cloud security for free at bridgecrew.io.
Hi, I'm Chuck Norris, and I'm here to explain what the heck incident management is. Picture this. It's Friday at 5 p.m. You hear it, the dreaded page. The server is down. Customers can't log in. Somebody dropped your database. Now what?
Well, Chuck, everything from this point on is incident management. Now you have to remember what the process is, who to call, when to update the status page,
and all of that manual work that no one wants to do on Friday at 5 p.m. Particularly me.
Not to worry though, we built Fire Hydrant to handle all of this. From declaring an incident either from a page to declaring it via our API or from Slack. From tracking, communicating, retrospective, all the way through, we have built Fire Hydrant to handle all of it. So that helps you get back to resolution quickly and back to your weekend.
When I deployed Lacework, I was able to detect things like, is somebody running Netcat on a machine? Is somebody sudoing and running something that they shouldn't be? I could use it to audit if there were a failure. I could see, well, what happened on this machine and who did what? And it's not to go and point a finger at a particular person and say you've done bad, but it's more to empower them and to tell them how they can do better. I've been very happy with Lacework. I've been a customer for about 2 years at Turnitin, and I'm going to continue to be a customer. They continue to excel as one of the experts in their space.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra DAS free to see how OPA can policy enable your cloud-native stack today.
Hello DevOpsDays Seattle. My name is Raf Bocino and I'm here to introduce you to Sky Crafters. Sky Crafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to Sky Crafters.
Hi, I'm Tim Davis, DevOps advocate with M0. I'd like to start off by thanking everybody with DevOps Days Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away, and hopefully everybody has a great time. Take care.
The challenge with building modern apps is that they require modern building blocks, like cloud-native practices, containers, microservices, and Kubernetes. It's a lot to consider. What you need is a full-stack platform for building modern apps. Tanzu Advanced simplifies and secures the container lifecycle, accelerating the delivery of modern applications at scale. Developers get a self-service experience with less toil, while ops can manage modern applications securely and more effectively. The result will be happier customers and the competitive advantage you've been looking for. Check out our website to learn more about Tanzu Advanced or any of the other Tanzu editions that are designed to meet you wherever you are on your app modernization journey.
Hello everyone, Austin Becker, Solutions Architect here at Sonatype. Modern developers leverage open source software to accelerate getting applications to market. The dilemma developers face is selecting which components to choose. Some have efficient tools to guide them in their selection, while others waste manual time researching these components. Sonatype's best-of-breed platform empowers developers to select the correct components that are non-vulnerable and also enforces security and legal policies throughout the software development lifecycle. This allows companies to align their security, development, and legal teams to more efficiently and securely get applications to market. Thank you.
Bridgecrew's developer-first platform is designed to find, fix, and prevent cloud security misconfigurations. With hundreds of built-in policies and native workflow integrations, Bridgecrew helps enforce security best practices across the development lifecycle. Leverage Bridgecrew's VS Code extension to get real-time feedback as you write Terraform, CloudFormation, Kubernetes, serverless, and other infrastructure as code configurations. Scan IAC files and directories before committing code to shared repositories with Bridgecrew CLI. Address misconfigurations continuously on each code change with Bridgecrew's native source control and CI/CD integrations. Bridgecrew also provides security as code fixes back into your workflow to prevent misconfigurations from being deployed. And if drifts occur in running resources and workloads, Bridgecrew detects them, alerts you, and provides automated remediations. With complete code to cloud visibility, you can be secure and compliant without slowing down. Get started with codified cloud security for free at bridgecrew.io.
Hi, I'm Chuck Norris, and I'm here to explain what the heck incident management is. Picture this. It's Friday at 5 p.m. You hear it, the dreaded page. The server is down. Customers can't log in. Somebody dropped your database. Now what?
Well, Chuck, everything from this point on is incident management. Now you have to remember what the process is, who to call, when to update the status page,
and all of that manual work that no one wants to do on Friday at 5 p.m. Particularly me.
Not to worry though, we built Fire Hydrant to handle all of this. From declaring an incident either from a page to declaring it via our API or from Slack. From tracking, communicating, retrospective, all the way through, we have built Fire Hydrant to handle all of it. So that helps you get back to resolution quickly and back to your weekend.
When I deployed Lacework, I was able to detect things like, is somebody running Netcat on a machine? Is somebody sudoing and running something that they shouldn't be? I could use it to audit if there were a failure. I could see, well, what happened on this machine and who did what? And it's not to go and point a finger at a particular person and say you've done bad, but it's more to empower them and to tell them how they can do better. I've been very happy with Lacework. I've been a customer for about 2 years at Turnitin, and I'm going to continue to be a customer. They continue to excel as one of the experts in their space.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra as free to see how OPA can policy enable your cloud-native stack today.
Hello DevOpsDays Seattle. My name is Raf Bocino, and I'm here to introduce you to Sky Crafters. Sky Crafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to Sky Crafters.
Hi, I'm Tim Davis, DevOps advocate with M0. I'd like to start off by thanking everybody with DevOpsDays Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away, and hopefully everybody has a great time. Take care.
The challenge with building modern apps is that they require
Welcome back, everyone. Thank you so much, Jeremy, for taking the time to answer the questions that came in about the Circle CI report. Now we're going to take a 10-minute break. We'll be getting started again in 10 minutes. It is currently 10:30 a.m. And so at 10:40 a.m. Pacific time, we'll get started again with 3 great Ignite sessions. So 10-minute break. Grab your coffee and water and whatever else you need to do, and see you in 10 minutes. Bye.
The challenge with building modern apps is that they require modern building blocks like cloud-native practices, containers, microservices, and Kubernetes. It's a lot to consider. What you need is a full-stack platform for building modern apps. Tell Tanzu Advanced simplifies and secures the container lifecycle, accelerating the delivery of modern applications at scale. Developers get a self-service experience with less toil, while ops can manage modern applications securely and more effectively. The result will be happier customers and the competitive advantage you've been looking for. Check out our website to learn more about Tanzu Advanced or any of the other Tanzu editions that are designed to meet you wherever you are on your app modernization journey.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra as free to see how OPA can policy enable your cloud-native stack today.
Hello DevOpsDays Seattle. My name is Raf Bocino and I'm here to introduce you to Sky Crafters. Sky Crafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to Sky Crafters.
Hi, I'm Tim Davis, DevOps advocate with M0. I'd like to start off by thanking everybody with DevOpsDays Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away, and hopefully everybody has a great time. Take care.
Hello everyone, Austin Becker, Solutions Architect here at Sonatype. Modern developers leverage open source software to accelerate getting applications to market. The dilemma developers face is selecting which components to choose. Some have efficient tools to guide them in their selection, while others waste manual time researching these components. Sonatype's best-of-breed platform empowers developers to select the correct components that are non-vulnerable and also enforces security and legal policies throughout the software development lifecycle. This allows companies to align their security, development, and legal teams to more efficiently and securely get applications to market. Thank you.
When I deployed Lacework, I was able to detect things like, is somebody running Netcat on a machine? Is somebody sudoing and running something that they shouldn't be? I could use it to audit if there were a failure. I could see, well, what happened on this machine and who did what? And it's not to go and point a finger at a particular person and say you've done bad, but it's more to empower them and to tell them how they can do better. I've been very happy with Lacework. I've been a customer for about 2 years at Turnitin, and I'm going to continue to be a customer. They continue to excel as one of the experts in their space.
Bridgecrew's developer-first platform is designed to find, fix, and prevent cloud security misconfigurations. With hundreds of built-in policies and native workflow integrations, Bridgecrew helps enforce security best practices across the development lifecycle. Leverage Bridgecrew's VS Code extension to get real-time feedback as you write Terraform, CloudFormation, Kubernetes, serverless, and other infrastructure as code configurations. Scan IAC files and directories before committing code to shared repositories with Bridgecrew CLI. Address misconfigurations continuously on each code change with Bridgecrew's native source control and CI/CD integrations. Bridgecrew also provides security as code fixes back into your workflow to prevent misconfigurations from being deployed. And if drifts occur in running resources and workloads, Bridgecrew detects them, alerts you, and provides automated remediations. With complete code to cloud visibility, you can be secure and compliant without slowing down. Get started with codified cloud security for free at bridgecrew.io.
The challenge with building modern apps is that they require modern building blocks like cloud-native practices, containers, microservices, and Kubernetes. It's a lot to consider. What you need is a full-stack platform for building modern apps. Tanzu Advanced simplifies and secures the container lifecycle, accelerating the delivery of modern applications at scale. Developers get a self-service experience with less toil, while ops can manage modern applications securely and more effectively. The result will be happier customers and the competitive advantage you've been looking for. Check out our website to learn more about Tanzu Advanced or any of the other Tanzu editions that are designed to meet you wherever you are on your app modernization journey.
We're Styra, founders of Open Policy Agent, a CNCF graduated project like Kubernetes, Envoy, and Prometheus. They unify container orchestration, networking, and monitoring. Open Policy Agent, or OPA, unifies policy. Our declarative authorization service is the way to deploy OPA at scale so platform, DevOps, and app dev teams can decouple authorization from underlying systems to innovate where it matters most and easily prove compliance across teams. Check out Styra DAS free to see how OPA can policy enable your cloud-native stack today.
Hello DevOpsDays Seattle, my name is Raf Bocino and I'm here to introduce you to Sky Crafters. Sky Crafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now scanning the QR code on the screen, and welcome to Sky Crafters.
Hi, I'm Tim Davis, DevOps advocate with M0. I'd like to start off by thanking everybody with DevOpsDays Seattle for allowing us to participate as a sponsor and be part of this excellent show. I am really looking forward to all of the awesome speakers and all the awesome sessions here that are going on. As far as, our vendor pitch that I'm supposed to be giving you right now, if you have any form of infrastructure as code that you need to automate, create self-service for, if you need to make sure that you're deploying it with governance and controls, we're definitely here for you. We are a tacos platform, Terraform automation and collaboration software, but we are not just a Terraform platform. If you want to bring your Terragrunt, if you want to bring Pulumi or CloudFormation, definitely feel free to check us out and we can help you out. Come by our Discord channels, ask us questions, see what's going on. We may have some cool stuff to give away, and hopefully everybody has a great time. Take care.
Hello everyone, Austin Becker, Solutions Architect here at Sonatype. Modern developers leverage open source software to accelerate getting applications to market. The dilemma developers face is selecting which components to choose. Some have efficient tools to guide them in their selection, while others waste manual time researching these components. Sonatype's best-of-breed platform empowers developers to select the correct components that are non-vulnerable and also enforces security and legal policies throughout the software development lifecycle. This allows companies to align their security, development, and legal teams to more efficiently and securely get applications to market. Thank you.
When I deployed Lacework, I was able to detect things like, is somebody running Netcat on a machine? Is somebody sudoing and running something that they shouldn't be? I could use it to audit if there were a failure. I could see, well, what happened on this machine and who did what? And it's not to go and point a finger at a particular person and say you've done bad, but it's more to empower them and to tell them how they can do better. I've been very happy with Lacework. I've been a customer for about 2 years at Turnitin, and I'm going to continue to be a customer. They continue to excel.
Welcome back to the show. At this point, we're going to change things up a bit with Ignites. Remember, Ignites are shorter 5-minute sessions about a more focused topic. You'll learn a little bit about team building, the dangers of doing things the way you always did them, and engineering in a political nonprofit. Let's take a look.
Do you ever feel productive, yet isolated with your team working remotely? I want to share with you the simple ways to create belonging within remote teams. Hey, I'm Najib from Teamland. So by now, everyone's used to working remotely, and we're kind of in our second inning of remote work. We have 80 plus people on a Zoom call, yet we feel isolated. And it happens, the loneliness aspect happens for a lot of people. The question is, how do we get your remote team to feel more connected than ever before? Well, right now, the reason why people are choosing remote work is they have to because of COVID. But why did people choose remote work beforehand? As someone who's worked remotely for 8+ years, some of the reasons are flexible schedule, being able to work from anywhere, no commute, spending time with family, and the ability to work from home. And because of that, our lives right now in the past year and a half got impacted because majority of the companies now want to continue a form of remote work post-pandemic. And because of that, talent as well, people want to continue a form of remote work, and a third will just flat out quit if they're forced to work remotely in the office full-time. Now, working remotely leads to higher productivity and job satisfaction. I mean, it sounds good, but what are the challenges? Well, for one, the two of the biggest downsides and struggles of working remotely is collaboration and loneliness. These two encompass 40% of the challenges, not including being in a different time zone than your teammates. We're connected every minute, yet still feel isolated. We have Slack, project management tools, video conferencing tools, notifications, and yet we feel difficult to connect casually with others. Now, it's not necessarily the tech, but without the proper use of tools, we're feeling left alone. Now, managers don't have it easy as well. When asked managers what they struggle with, 70% struggle with maintaining company culture and team cohesiveness. So, what do we do? Well, first thing, the bad news first is that creating belonging isn't a one and done activity. In fact, it's like farming or working out. Now, the good news is that just like working out, it takes time, but there are also different ways of doing so. If you look at the 4 stages of a team, forming, storming, norming, and performing, you want to address each aspect differently. When you're starting at a company or the team is forming, you want to look at how are you onboarding everyone. Now, before it used to be, hey, we just go out for a happy hour, but now it has to be done purposefully, whether it's activity employee-led or company-led activities. Now, when it comes from storming, it's conflict resolution that impacts belonging. And it's related to having empathy and understanding, whether it's coming from the manager or the HR. Now, when it comes to norming, the other aspect of norming is cooperation, entertainment, deepening relationships. Now, these can happen both synchronously and asynchronously. And by creating shared experiences through activities, that is what creates bonds, whether it's something as simple as playing trivia or doing a virtual escape room. But keep in mind, they're not all the same. You want to make sure that it's truly what builds trust when spending time when it's done effectively. Now, lastly, performing, and this is where motivation, recognition, self-fulfillment comes into play. And these are balance of both intrinsic and extrinsic. If these are not looked after, it can lead to burnout. And this is where giving praise, affirmation, rewards helps, but not on the surface level, on the deep down aspect. One of the interesting quotes that I heard from one of the events that we've hosted is, I like this party because there's no pressure to drink or dance or dress up. We have to realize that we're all in this shared struggle, yet we have to make it work uniquely for each employee. Whether it's a virtual cooking class, a yoga meditation, or a weekly games night, there are a lot of options. But what do you do? I get this question from a lot of managers. What team building activity should I do? It always starts with the goal. Do you want to get to know others casually? Do you want to have cooperation, motivation, or entertainment? Once you know that, you can figure out other options. And it can take something like 5 to 10 hours a month to doing it, but doing it allows you to improve the productivity, mental health, and well-being of companies, because that's what's needed. If you want to learn some more ideas of what to do, of team building ideas, we have a simple generator on our site, Teamland. So just check out ourteamland.com. And my name is Najib. If you have any questions, you can reach me out on Twitter or LinkedIn anytime. Thanks for listening.
Hi there. Welcome to Steel Copy of a Wooden Bridge. My name's Derek Ashmore. I'm from Asperitas Consulting in Chicago. Steel copy of a wooden bridge is a phrase that my grandfather used to use and I picked up. The way I interpret it is that when new things come along, be they materials or be they technologies, you don't necessarily use the same techniques that you used in the past when adopting the new technologies. And I think this applies to cloud adoption and DevOps automation. I've seen customer after customer effectively try to create steel copies of a wooden bridge with cloud adoption and DevOps automation. And the result is usually frustration, and they usually do not get the benefit out of the cloud that they sought. So I'm going to take you through some of the common tactics that our customers use and things that we've found that appear to work in some of our more mature customers. Let's level set at the beginning of the story. When our customers migrate to the cloud, or when companies generally migrate to the cloud, they do so for perceived benefits. They perceive it's more cost effective. They perceive that they can get to market with new business capabilities more quickly. They perceive that they can get out of the data center business and not have to worry as much about buying, renting property and things like power consumption and racks and all that kind of stuff. And they also want a global reach. Increasingly, companies are moving worldwide, and cloud vendors seem to be able to be able to move your assets and workloads and applications closer to the user so that they get better performance. There are probably other benefits than just those four, but those are big ones. Why use DevOps automation? Basically, it helps your cloud footprint grow and shrink with your business. If I want to spin up new environments with automation, somebody feeds that automation some different parameters and hits a go button. Once it's created, it's very easy to create new environments. Environment consistency. We have all seen the problem where this application works in dev, it works in UAT, but it doesn't work in production. DevOps automation makes each and every environment consistent, which reduces that kind of problem. It also gives you productivity increases in the long term, right? Initially, creating an automation for a given environment or a given application or a given network spoke takes some upfront time. But once you have it, you automate once and deploy many times. And so over the long haul, you get some admin productivity improvements. And you also get reduced error rates. Most errors, in my experience, and your experience might be different, most errors come from manual work where somebody accidentally forgot to do something or somebody accidentally did something differently in production than they manually did it in UAT. And automation basically reduces that error rate. Also, the beginning of the story, what do corporations do when new technologies come in? I'll tell you what they do. The universal answer is they create a new silo. And we see that. We see that today. We see that in terms of networking teams, security teams, database administration teams. Any new technology that comes out seems to get a new silo or get incorporated into an existing silo. And when cloud adoption came out, basically I've had 4 different customers that created a cloud center of excellence or something along those lines, and at some point deprecated that silo as not really working for them. And we're going to go into why that is, but in essence, creating a silo is an example of a steel copy of a wooden bridge that we're going to talk about. All right. Soon after cloud adoption happens, you get the sales pitch violations. Customers routinely see security breaches coming from their cloud footprint, availability failures.
In my first few jobs, there was a strong emphasis on engineering culture best practices. If something was tested manually, that was a code smell. If any of our infrastructure was, let's say, artisanally managed, the infrastructure team would get an alert. I was immersed in that culture. I thought that following those best practices was the only way to have a healthy engineering team. I even aimed for 99% test coverage on my personal projects. I still think that they're best practices in a lot of situations, but now I think a lot of it depends on context. In 2019, I left my job at a startup and went to Empower, a progressive political tech nonprofit. The engineer who brought me on didn't focus on those best practices, which made me pretty apprehensive. So he told me that we could spend more time on testing and automation when we needed to, but he also asked me to see how well things would work with less process. We've all heard that premature optimization is the root of all evil, but a lot of us only think about that in terms of code, and we still prematurely optimize our processes and infrastructure. So I decided to trust him, and our approach going forward was to wait until something was a problem before we fixed it. Sometimes the quick and easy way never became a problem. For instance, a lot of folks at places like Google architect their code from day one to scale to billions of users, which can add a lot of complexity. At Empower, our model is called relational organizing. We're trying to push back against the trend of impersonal political spam and instead get people to have real conversations with their friends and family about issues that are important to them. That context means that Empower isn't ever going to have billions of users. We're already big and we're growing over time, but we scale by getting people to have in-depth conversations. So we just use a MySQL database, and that will probably always work for us. In other places, like testing and reliability, we've partly adopted a best practice. We put a lot of effort into testing some parts of the system, like anything security critical. We have monitoring for downtime, latency, big changes in metrics like new users. And we have end-to-end tests that make sure that all of the main user flows work, but we haven't invested much time in unit testing. The monitoring and testing that we do have takes very little time to maintain, and it all runs very quickly, and it's got a bunch of issues, so it doesn't feel like we have any more bugs than when I was on teams with 99% test coverage. Partly, that's because we're a small nonprofit, and all of our engineers are pretty senior. Also, we make sure that we keep things simple, don't have too many pages in our app, and all of that means that it's a lot easier for an engineer at Empower to keep all of the code in their head. So there aren't as many bugs due to complex interaction between different parts of the codebase. And when there is a bug, it's easy to track it down and fix it. Big companies still probably need to invest in unit testing, but I suspect that a lot of startups could probably get away with only a medium investment in testing. There are other places where we've gone above and beyond the best practices. For instance, there's a lot of seasonality in political tech. I'm still at Empower, we're doing good work to help get people vaccinated and to combat misinformation, but a lot of people join up because they're interested in an election and then they leave afterwards. That means we put a lot of emphasis on code reviews, knowledge sharing, making sure our code is simple, modular, easy to understand. And code reviews and modularity are best practices everywhere, but there's a difference between just giving them lip service and making them a big part of the culture. Managers giving feedback to their employees about code reviews, discussions on the team about naming our functions, the product manager narrowing the scope of a feature in order to make it simpler and easier to maintain. There's a lot that you can do if you make it a priority. So I'm not saying that you should throw best practices out the window, but I have been on teams that spent a lot of time trying to do the supposed right thing, even though it ended up being a premature optimization. The important thing with any part of engineering culture is understanding what problems you have at your specific organization and how to fix them. Sometimes that means following best practices, and other times it means accepting tech debt because it helps you get a few more people to register to vote. Thanks everybody, and if you want to talk engineering culture or hear more about political tech, hit me up. My email is samking@getempower.com.
Well, thank you so much, Najib, Derek, and Sam for those great ignites. Well, as you might have noticed, we made a little bit of a mistake there. So we had specific time set up for Najib, Derek, and Sam's talk, but we had two talks for Derek. We had a 5-minute and a 20-minute, and it seems like the 20-minute one got injected in where the 5-minute one should have been. So sorry about that. When we go in and edit the stream for later publication on YouTube, we'll make sure the correct 5-minute session is there where it should have been. But we're also going to post Derek's longer version of that talk as a separate add-on extras at the on our channel as well. So that will be there, so you can see both versions. Yeah. Sorry about that, but I guess in the words of, what was that great video from, we're doing it live. Now, let's move on to talk about machine learning and how you can leverage your DevOps experience and processes to management and operations of ML models. Mita Dash from Verta will talk about CI/CD and release management for scientists and monitoring and observability of those models in this great talk.
Hello and welcome to today's session. My name is Meeta and I head product at Verta, an ML operation and model management platform. Thank you for joining me today, and I'm really excited to talk about how we can bring current DevOps maturity when we are operationalizing machine learning initiatives. Now, these are some of the key areas that we'll explore today. First of all, we'll talk about why do we need MLOps, current challenges and gaps. Then we'll talk about bridging MLOps and DevOps, bringing the DevOps best practices to MLOps, and also how can we effectively leverage DevOps processes and tools for machine learning. And next we'll have a demo and we'll wrap up. If you talk about ML models today, they are on the critical path for every business. Financial industry is increasingly applying AI in areas like robo-advisors, anti-money laundering, and many more. Fraud prevention is another big area where companies are investing heavily, and machine learning is helping a lot. We are seeing similar trend in healthcare in variety of applications, from machine learning based disease diagnostics, image analysis, drug research, or even assistive surgery. Manufacturing is seeing an explosive growth with sensor, IoT, and robotics. Better credit card decisions are made using machine learning. And ML has a big role to play in building the future of retail experience, from supply chain optimization to customer service to making a purchase using a robot. By the year 2024, 75% of the companies are planning to move their POCs or pilots to actual production application. But here's a reality check. We are still struggling to move POCs and pilots to actually deploying in production and really scaling. If you look at the current state of ML operations, these are some of the challenges that we are hearing again and again from different teams. First of all, data scientists should be free to try different frameworks. There is a whole host of frameworks and tools available that can help them innovate and move faster. But at the same time, it creates a difficulty to manage different tools and govern them across the board. The second area where we are seeing the challenge is, this is a quote from an ML engineer from a workplace messaging app. Every time we wanted to roll out a model, we had to build a brand new prediction service and support it 24/7. So operating and running models is a challenge, and some of the teams build one-off solutions, which creates a nightmare for IT team. The third area is just the sheer nature of number of models that is being built and the way they are built. Models are built with different frameworks. They run in different places like batch or online inferences. There are so many other platforms that teams are free to try, which is good. But at the same time, it's difficult to manage them. And teams are increasingly facing the challenge that there is no central place to get visibility on what models are running, where they are running, and how they are performing. And last but not the least, there is no way to know if a model is underperforming until customers actually complain. So there is a lack of model monitoring best practices and tools that bites us back when it comes to operationalizing them. So I would say that the state of the art for ML operations is something like this. There are too many ad hoc processes. ML models are a black box to most of the teams. This is aggravated by the fact that we use a lot of out-of-box models, or even one team builds a model and another consumes it without knowing the details, which creates operational problems. There is release handoff process, which is not that well defined. And then at the end, we use tools that are completely misfit and not built for data science teams. That also slows down the process. And if you look at the software world and draw parallels to it, we have a fairly mature DevOps processes, and we have tools that manage the entire DevOps lifecycle, from planning to developing to packaging, releasing, and monitoring. If you look at ML ops, we would expect a similar workflow, right? We want to deliver ML models faster and more reliably, and the lifecycle and the stages are more or less the same. But we lack the tools. We do not have mature tools and processes to help us operationalize this. But fortunately this year, we are seeing a rise of a new breed of MLOps tools and platforms that is helping fill the gaps. And in this talk, we'll talk about Verta platform, which is an MLOps platform to help address these gaps. But before diving into any tools or processes, let's closely look at the key points of friction or bottlenecks that slows down ML rollouts. The first point that I'll be talking about is how we develop models. The model development is a little bit different than software. It's very empirical and ad hoc. The data scientists start with a simple model code, but they keep tuning and they run multiple hyperparameter search. Maybe they will change the data or completely change the feature set that is used to train the algorithm. Finally, they come up with a model with an expected accuracy. And a lot of data scientists run these experiments in their local environment that may or may not track all the iterations. They may be tracking them via a spreadsheet. It could be fairly manual. But when we think about model operations, you need to guarantee reproducibility. You want to ensure that there is proper governance in place. And if you release a model, you want to go back to the exact state of the model and recreate that the output, right? So to add to the complexity, model code is just not enough to give you that reproducibility that you're looking for. And let's say if you want to go back to experiment number 501 and try to make it reproducible, what do you actually need? What we have seen is these are the key ingredients that is really needed and should be tracked to ensure consistency and reproducibility for machine learning. The first one being, of course, the model code, which is the algorithm that is written. But then it is equally important that you have the underlying data that is used to train the model, as well as the configuration, which are the hyperparameters and similar metrics that has been used to train the model, as well as the environment variable, so underlying libraries that is used to the exact version number. This is where an experiment management system really helps, where you are tracking all your experiments and iterations and all the underlying model code, data, variables, and everything, so that when you are releasing a model to production, you can effectively go back and reproduce the same behavior. The next place where things break down is the release handoff process. Typically, data scientists, they iterate and run tens and thousands of iterations, but they are not comfortable sharing those iterations with the entire team. And again, the team may not be interested in that, but rather the best fit model that is deployed. And the ad hoc process makes it harder to identify which models are production ready. And then when you decide to hand off the model to engineering, your machine learning infrastructure or operations team, that's where the handoff process kind of is not that elegant and things break down. So what we lack is a better transparency and collaboration between these teams, and have a central point of synchronization where your production ready models are staged and the folks who are deploying it can just pull from there. And that's where a model registry plays a much bigger role, because it kind of is a linchpin between ML and ops, where all your staging models are registered, and you move the model through its life cycle. Machine learning work with your current CI/CD release process. And typically you would, when the model is ready, you fetch the model, you would be running some quality tests and validations, you would be containerizing the model, and then deploying it to different clusters, development and production. And again, the model could be a live model where you're serving live inferences, or it could be a batch model. You need to make sure that it works well with your existing CI/CD process. You don't want to reinvent and create one-off release process. So going back to the ML ops lifecycle, deployment and operationalizing your model and serving and reliably scaling it is an important part. And what another challenge that teams are facing is monitoring and debugging machine learning in production. And what makes it harder is I put them into these 4 buckets. The first one is measuring ML models quality, right? It's extremely important to measure model quality in absence of ground truth data, because let's say if you talk about a product recommendation engine, if the model is predicting and recommending a product to the customer, how do you ensure that it's giving the prediction with higher quality unless you kind of match it with a ground truth? And it's sometimes very expensive, and it's time consuming to create ground truth and calculate model accuracy. So just guaranteeing model quality is a big challenge, and measuring it. The second area is customization. Each model is unique, and the way you are calculating its metric, the way you are visualizing it is very different. The simple example is if you are building an NLP model versus a computer vision model, they're way different how you track them. So just building a tool, a monitoring product that works across the use cases is a challenge. The third area is just simply the pipeline chaos, because the models are built with a very complex set of data pipelines, and there is model code, there is training data. So doing the root cause analysis is extremely hard, and the things can break down in different places. And finally, the problem around models being black box is another thing to consider, because of the complex process in which models are built, and also as more and more teams are using off-the-shelf models. It's extremely difficult to know why the model is behaving in certain way. And finally, I would also highlight that typically model service health monitoring, like latency, throughput, they're important, but they're not enough, because ultimately you need to understand and track the model quality, its data distribution, how the pipeline is doing, is there a failure in the pipeline, and all these things need to be tracked so that you can ensure that and guarantee that the model is performing as expected in production. Monitoring is a key piece here to guarantee that you're operationalizing and scaling your ML models. And finally, the streamlining your end-to-end ML operations rely on these 4 areas. The first one is how you develop models, managing the experiments and making it much more reproducible and reliable, and feeding that process back to registry where you are tracking and staging your models and managing the entire ML model lifecycle, and then deploying and scaling and operationalizing them, and finally monitoring them to guarantee that the model is performing as expected. Now I'll show a quick demo of Verta MLOps platform to just walk you through our approach to solving these MLOps challenges. The entire team to get access to all those iterations, right? But for model governance and release, one could be building an NL, and then with your CI/CD and release process, and it fits into your software release cycle as well, because the models are not running on their own. The model API is being called by another software application. So the more tightly integrated they are to your CI/CD process, the faster you can roll them out, and there'll be lesser bottlenecks. And don't try to create more ad hoc processes for machine learning, but bring it to your DevOps process. So again, I want to bring back that point that you have to build the tooling that operates with your DevOps tools, and so that you can release models reliably. So deployment and inference serving is another key area which folks should be focusing on. And the last point is, once you have deployed in production, how do you guarantee that it is operating as expected, it is reliable, and it's giving the expected output, and it's giving a good user experience. But the challenge here is it's hard to monitor and debug ML models in production. And that really boils down to these 4 areas. The first one is measurement. How do you measure model quality? It's sometimes really difficult because I can go back to the example of a prediction model, right? A product recommendation prediction model. The model is giving some product recommendation to the user. There is no way to ensure that the model is giving high quality output unless the user complains or we have the right ground truth data in place. And for the ground truth to be generated, it's a manual process, and it cannot be done immediately. It takes time, and it's costly as well. So a lot of teams struggle with ensuring that the model accuracy is of high quality in production in real time. And the second area of challenge is just customization, because each model is unique, and as so as the quality metrics. So even if you're building a monitoring tooling, you're building monitoring processes for your teams, the teams would be dealing with very different models. If you are building an NLP model, you are looking at n-grams and metrics that are way different than if you are building a image a classification model. So again, that adds to the complexity. Just the customization and the type of data that the model is dealing with can lead to the data scientist using very different charts, very different visualization, and very different types of metrics for model monitoring. The third area is, of course, pipeline chaos, because the models are relying heavily on the data. So, and the data comes from a very complicated data pipeline. You may be having an ETL process where you're cleaning up and transforming your data, and then finally it feeds to the model for training. And so there are multiple failure points when it comes to model performance in production. And just because of this chaotic environment where there's so many layers of failures and so many layers which are not visible to everyone, not having that transparency also adds to the problem where if your model fails in production, just debugging it becomes really hard. And last but not the least, the black box effect, which is very prevalent now, adds to the complexity as well, because the modeling process is complex in itself. At the same time, teams are more and more using off-the-shelf models to go to market faster, but that kind of hinders just the model is not interpretable for the teams, and it's a black box. So model fails, it's again very difficult for you to know why is it failing, because you do not know how it is built. So these 4 together makes the model monitoring in production, and more importantly, debugging and doing root cause analysis a big challenge. I would say the typical model service health monitoring, like latency, throughput, is not enough. It's important, you have to do it, but it's not enough. You have to think about the other criteria that I just mentioned. So going back to the problems and what slows down ML ops and how can we address it, the fourth area is how we monitor models in production, and having thinking through all the complexities of model monitoring and addressing them as depending on where your team is and what use cases they're building towards is equally important. Now for a more comprehensive model monitoring strategy, this is what I would recommend. Start with model data and pipeline monitoring. That includes monitoring your input and output data and any intermediate results. This also includes looking at the statistical property of your model, such as drift in distribution, null values, outlier, missing data, and things like that. The second area is thinking about model performance. How do you calculate quality metrics like accuracy, F1 scores, etc.? And that also would be, it's important here to think about how do you collect ground truth and label your data. The third area is, of course, service health, which is about model latency, throughput, and resource utilization. And think about model explainability, like how do you monitor bias, how do you do cohort analysis, and finally closing the loop. It's just not about monitoring your model and getting notifications and alerts. It's also about how do you automate the next steps. That could be starting your retraining workflow or something similar, but just thinking through how do you close the loop and automate. Now to summarize everything, MLOps is in a very critical juncture right now. And when you think about an end-to-end machine learning operations in production, we have to think about these 4 key components. The first one is experiment management, where you are bringing the model development process and streamlining it to make sure that the model is operational in production, which involves making sure that the model is versioned correctly. You are managing the metadata of the model and making it reproducible. And then next, you are thinking about model registry, where you're creating one unified hub to manage all your model lifecycle and managing model testing, introducing CI/CD automation, and making sure that the entire team is collaborating in one single place. Then you have to think about model deployment, which involves both online inference servings as well as batch, making sure that you are deploying safely and you have the right tools to auto scale. And finally, model monitoring, which is a big beast in itself, which involves model performance, drift detection, retraining workflow, and much more. And you have to bring all these pieces together, but at the same time, think about your DevOps practices and make sure that the DevOps practices and ML ops practices are working together, and you're not building ad hoc or one-off solutions for machine learning. Thank you for your time today, and I'm happy to answer any questions that you may have.
Hello, DevOpsDays Seattle. My name is Raf Bocino, and I'm here to introduce you to Sky Crafters. Sky Crafters is an inclusive community where novice and seasoned cloud practitioners can find information answers quickly, bounce ideas off each other, and work through challenges together. We have curated valuable content, amazing open source code to use or contribute to, and a safe place that we hope is going to grow your cloud skills and career alike. Join the discussion right now, scanning the QR code on the screen, and welcome to Sky Crafters.
Bridgecrew's developer-first platform is designed to find, fix, and prevent cloud security misconfigurations. With hundreds of built-in policies and native workflow integrations, Bridgecrew helps enforce security best practices across the development lifecycle. Leverage Bridgecrew's VS Code extension to get real-time feedback as you write Terraform, CloudFormation, Kubernetes, serverless, and other infrastructure as code configurations. Scan IAC files and directories before committing code to shared repositories with Bridgecrew CLI. Address misconfigurations continuously on each code change with Bridgecrew's native source control and CI/CD integrations. Bridgecrew also provides security as code fixes back into your workflow to prevent misconfigurations from being deployed. And if drifts occur in running resources and workloads, Bridgecrew detects them, alerts you,
and I'm here